Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Dari Syafi binti Muhammad Salimi and my matrix number is 01DTK24F1022. And I'm going to show you the demonstration of practical work generic skill topic 3. For the introduction, is talk about the bipolar junction transistor or BJT. BJT is a key component in electron circuits. Is it a type of semiconductor device that has three terminals, the emitter, base and collector, and is mainly used to amplify or switch electrical signals. And there are two main types of BJT, which is NPN and PNP, both of which operate based on the movement of charge carriers through the layer of semiconductor materials. BJT are widely used in amplifier, signal processing, and electronic switching, making them highly significant in both analog and digital electronics. So here's the tools that I use for this practical work 3, which is multimeter, wire probe negative and positive, and transistor 2N222. So we need to plug the probe to multimeter in reverse position, which is black probe plugged to positive and red probe plugged to negative. Here's the position of transistor 2N222. First, we're going to do zero adjustment and set the range. Red probe at terminal 1 and black probe at terminal 2. The result is infinity. And the second is red probe at terminal 1 and black probe at terminal 3. For the result is infinity. Third, red probe at terminal 2 and black probe at terminal 1. For the result is 65 ohm. Fourth, red probe at terminal 2 and black probe at terminal 3. For the result is 65 ohm. Fifth, red probe at terminal 3 and black probe at terminal 1. For the result is infinity. And then, red probe at terminal 3 and black probe at terminal 2. For the result is infinity. So here's the table. Focus on transistor 2N222. And then you can see what terminal are the same at red and black probe. For example, number 3 and 4, it's terminal 2. So terminal 2 is the base. Then I will talk about the BJT terminals and the function. Let's start with the base. The base is the control terminals of the BJT. It's a very thin and lightly doped layer placed between the collector and emitter. A small current or voltage applied to the base controls a much larger current flowing between the collector and emitter. And next, we have the collector. This is the terminal through which the main current enters in NPN or exits in PNP, the transistor. It's called the collector because it's collect the charge carriers that are injected from the emitter and controlled by the base. And for the last, there is the emitter. This terminal is heavily doped and its main job is to inject charge carriers, electrons in NPN and holes in PNP, into the base region. These carriers then move to collector, completing the circuit. The emitters emits the majority of the current in the transistor. Now we'll talk about the current flows in both NPN and PNP transistor. In NPN transistor, when a small current flow into the base, it allows a much larger current to flow from the collector to the emitter. And then for the last, PNP transistor work in the opposite direction. When the base is made slightly negative relative to the emitter, it allows current two flow from the emitter to the collector. In this case, current enters the emitter, flow through the collector, and the base current flows out. So for the step 1, we need to zero adjustment, and then black probe at the base and red probe at the terminal 1 and 3. And for the result is infinity, and it's NPN type. And second step, we need to zero adjustment again. And then this one, red probe at base and black probe at the terminal 1 and 3. So transistor 2N222 is silicon, and terminal 1 is emitter, terminal 2 is base, and terminal 3 is collector, and it's NPN type. So we'll talk a bit about the conclusion. In conclusion, this experiment has helped us understand the fundamental aspect of the bipolar junction transistor or BJT. We explored its three main terminals, the base, collector, and emitter, and learn how they work together to control current flow. We need also identify the two main BJT types, NPN and PNP, and observe how current flows differently in each. Additionally, we discussed the materials used in BJT, particularly the advantage of silicon over germanium, with silicon being the preferred choice due to its stability, reliability, and performance at higher temperature. And that's all for me. Thank you so much.